Good afternoon. Can you hear me? Today you can unmute yourself. You can talk because I have kept that privilege. Okay, okay. All right. So, anybody, please unmute. Just let me check. You can unmute actually. You can unmute yourself. Yeah, you can actually. Okay. Okay, okay. Let's see. All right. You can hear me properly, right? There is a hand raise option. Just try the hand raise option. Just hand raise option. Yes, 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 yes. I can see that. Monica. Okay, okay, okay. Okay, it's working. Okay, you can down your hand. You can down your hand. All right, all right. All right, you can down your hand. Fine, fine. So what you can do is, if you are not able to unmute, so you can use hand raise option. I can immediately see you. So if you want to speak, you can use the hand raise option. Okay. Okay, so you can down your hand. Okay, you can make it down. So let us start today. Any doubt in previous class? Yes. If you have any doubt, you can put it. So I'm going to share the screen now. Okay. All right. So just let us check whether you're able to see my screen. Okay. I hope you can see my screen. All right.
कोई no relation between shearing string and relationship between a shearing string along with string and
All right. All right. So let us start. So today we are going to discuss relationship between uh, not audible. Okay. Now I think it is audible. I think it is audible. Okay. By the way, okay. 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 Vibrating. All right. Now, okay. Now, now is it okay? I think now it is fine. All right. So, but you can hear, right? You can hear. Okay. Disturbance. Yes, audible. Fine. So, how was the exam? How was the test yesterday? Is it solvable? You can put it in the chat box. Yes, it will be a little bit tough because you have the material, right? You have the material to access. So it is, but actually it is easy question only. Only thing is you have to understand what I have given. That's it. You have to analyze the problem. You have to analyze the problem. Okay, you have to analyze the problem, and you have to understand what exactly you have to understand. For example, uh, material it's available. Yes, it's how I can give direct. Huh? It's not. So I am checking your understanding. How much you understood whatever I have taught. How much you understood. This is called as open book test. This is nothing actually book test. So it will be still critical. AICT is actually recommending for open book test instead of closed book test. Which one you prefer now? Closed book test or open book test? Yes, if it is open book test means they will ask such type of questions. So you can take your all book notes, everything to examination hall. But only thing is the questions will be bit difficult because it is analysis type. So they will check your understanding. They will check your understanding. So that's as per my knowledge, it is important actually. It's important to check your understanding rather than show that, prove that, obtain expression. These are all are available in the textbook. Why you have to again derive it? I don't think when after completing your engineering, of your client will come and ask you to derive this formula and other thing. Finally, it is application of that. It's application of that. How best you can apply. For example, whatever I have given yesterday, uh, design a shock absorber. Simple. Design a shock absorber. As soon as I used word design, you people became totally blank. I know. It's not that just wordings. You have to understand what is the meaning of that question. What actually I am expecting. What exactly my expectation. You have to understand that. The first thing is take that problem. You analyze what exactly the problem. Problem is you have to design a shock absorber. What are the critical parameter for a shock absorber? You know, we have discussed that in the class. The shock absorber is a case of critically damped. Shock absorber is a case of critically damped. So critically damped means you should understand uh, b square is equal to omega square. That should be equal. So therefore, what are the data given? Just check. Yes, explain the strategy. That is what exactly I am doing now. That's what exactly I am telling. The strategy I am explaining. Strategy is this is what exactly you have to write. So shock absorber means that it should be critically damped. That's the first sentence. That's the first thing. So critically damped means b square is equal to omega square. Yes, you have given the strategy. You have given the strategy. So find out what is the data given. K is given. Force constant is given. Then mass of the object is given. So then automatically K and M is given. So you can calculate omega. Omega is equal to root of K by M, or omega square is equal to K by M. Okay. So you can use that. You can use that. And uh, you can calculate omega square. Once you calculate omega square, you can check B. Okay. B square. It should be equal to B square, critically damped. So B square you know. So that means you should know gamma value. You have to design a gamma value. So that's what exactly. Finally, you have to find out a gamma value, damping constant value. That is gamma by M is equal to 2B. So that is gamma by 2M will give B value. Correct? So B square is equal to omega square, so therefore you can get B value. Once you get the B value, calculate gamma value. Simple. 2B divided by M. That will give gamma value. That's what exactly you have to, that's a parameter you have to give. This should be the gamma parameter for critically damping for a shock absorber. If you do that much, actually what I asked, if I give you a direct question, same question can be asked directly. Find the value of damping constant gamma. Given force constant, mass. There is no question of talking about shock absorber, nothing. Actually, it is a case of shock absorber. That's what exactly. So, is it okay? So, some of you have tried seriously. I just gone through. Uh, some of you have seriously tried and try to get the answer and other thing. Okay. So, that is what exactly strategy means. You have to understand the problem, what you have to calculate. That's what exactly. Okay. It's okay. So let us discuss if you want uh, solution and other thing in another class. Let us do that. Okay. Once I complete the evaluation of the all the paper, I will do that. Okay. Let me see all the paper. So some of the paper I have evaluated. Okay. Is it okay? Priya, you have asked for solution. So we will discuss a solution for that. Okay. But I don't think it is not that you cannot solve it. Only thing is you have to sit and think and calculate. Actually, problem is a small problems only. Small problems. It may take 5 minutes to solve that. But I have given 1 hour because you have to apply, think and identify which are the parameters. Since it's the first time, you may find it difficult, but if you do such type of 2 3 test, 2 3 2 3 test, you will be used to it and you will understand how exactly solve that. Actually, if you ask me, this should be the pattern of the examination actually for all subject actually. This should be the pattern. Then you can be a real engineer. But it so happens that most of the time, yes, Sumukha, I can give you more questions so you can work out. Okay, I can give. I have such plenty of such questions I have collected, so I can share, no problem. Okay, so because I'm very happy to solve that. Please understand, open book test means it is not test for student only, it is a test for me also. Look at that shock absorber question, you cannot find anywhere in the online. You cannot find. So it is the values, everything is designed by me. It should be like that only. It should be like that only. Because if something is available in online and copying and pasting, then uh, okay. So that's good idea, Monica. That's good idea. So Monica says solve such type of problem in the class also. Yes. Uh, I will do that. I will do that. 2 3 questions. I will take such type of problem, and I will do that. That's a good suggestion. I will take it. Okay, that's a good suggestion. But generally, I don't do that in the class because uh, most of your if you are exam oriented in the examination, such type of problems are not asked. But in real life situation, if you are thinking, such type problem only comes in the real time, real life. That's a actually gap between subject and real life. Actually, so many times we say, so we learn this all differentiation, integration, everything, but it is not coming in your day to day life anywhere. Why we have to study that? Simply waste, we say. But only thing is we are using in so many places without knowledge. So if we had that knowledge, we are exactly using here. Here we are using. Then we could have used it better way. Better way. That's what exactly. Okay. So that's fine. So let us move ahead to today's class. So we have to complete 2 topics today. This useful for gate exam? Yes, of course. Is this useful for gate exam? That's a question asked by Sumukha. Yes, that is this type will be useful. This type will be useful at exam. Okay. Okay, option. Okay, that I am going to do that such type of test actually. Soon we are going to have internal test. Internal test. There are two types of internal tests planned by the college. One is multiple choice. Multiple choice. You will have four answers. But thing is, problem will be like similar type of, okay, similar type of problem. Sometimes you have to solve. Sometimes you have to apply and give the answer. Apply your knowledge and give the answer. So such type of problem questions will be asked if it is a multiple choice. So roughly there will be 20 to 30 questions. You will be given 1 hour. Okay. So some are direct questions, some are applied, analytical. Okay. All right. All right. All right. Yes, yes, I will do that. So, Mayur is asking for a demonstration of such questions. So, I will take one question and I will explain how exactly before going for internals. Okay. All right. So, today participation is very poor. Only 36 people have entered into class. Okay. Fine. So, people are not serious about online class. All right. So, I will take this very seriously. All right, today what we are going to see. So today we are going to see relationship between shearing strain, elongation strain and compression strain. So today we are going to see shearing strain, elongation strain and compression strain. So how exactly this works, let us see. Relation. Okay. So shearing strain, to understand that. Okay. So let us consider a cube. Let us consider a cube. At any point, if you have doubt, either you raise your hand, raise your hand. Shramik, please down your hand. Shramik and Akash, please down your hand. Again, click on that. The hand will be down. Yes. Shramik, again click on the raise hand. Your hand will be down. Otherwise, it will be confusing for me because your hand raising. Yes, yes. Please down your hand. Shramik. Okay. If anybody has want to talk, you can raise your hand. I will unmute you. Okay. Yes, Shramik, just click on raise hand so that your hand will be down. Lower hand. Yes, click on raise hand again. Okay, all right. So let us consider a cube. Okay, let's consider a cube. So having one at bottom, you can see CD. CD is the bottom of the cube, which is fixed. Okay, and you are applying a deforming force F. That's a tangential force F onto this cube. Then what exactly happens? Then what exactly happens? So you see that it undergoes a deformation. I think you can see my uh, mouse pointer, right? Okay. So force is applied. Force is applied. A tangential force is applied. So because of that, okay, force is applied in this direction from the top. So the cube will undergo shear. So because of the tangential force, then what exactly happens? The point A, corner A, okay, shifted to A dash. B is shifted to B dash. B is shifted to B dash. Okay. Now, all right. Then the shearing, let us say there is a by an amount of theta. Theta is amount by which it is sheared. Okay. Then what exactly happens? Diagonal undergoes a compression. You can see the diagonal. You can see that diagonal AC get compressed. Correct? The diagonal length is reduced. So now new diagonal becomes A dash C. A dash C. Okay. So when you shear, so point A becomes A dash. So now whatever dotted shape is a new shape, sheared shape. Then the diagonal will be A dash C. A dash C. So it is compressed. In the same manner, the diagonal, okay, diagonal E dB get extended to the dB dash. Okay. So now you can draw a right angle. You can draw a right angle perpendicular to AC so that perpendicular to AC so that it connected at A dash. That is A dash M is perpendicular to AC. Similarly, you can draw a B dash N perpendicular to DB dash. Okay. All right. Now, so the length of the cube, let us say capital L, and small l is the displacement. Small l is a displacement. Okay. So that is A dash and BB dash is a displacement that is by small l. So since theta is very small, whatever we consider, even though in the figure it is shown very big deformation, but it will not like that. It will not be like that. So it will be a small deformation. It will be a small deformation. Whatever deformation is there, that will be very small. Okay. So therefore, we can write that is shearing strain. Theta is nothing but shearing strain. Okay. So theta is equal to tan theta by definition. We can write L by L, small l by capital L. So now, a few minutes before we have discussed, regarding that's one diagonal undergoes extension, which is at dB is the diagonal which is undergoes extension. Okay, you can see that dB is the diagonal which undergoes extension. All right, and AC is the diagonal undergoes compression. AC is the diagonal which undergoes compression. All right, all right. So now extension strain along dB. Extension strain along dB. So it is strained because of the extension. You have, when you apply force in this direction, so this is extended. This diagonal is extended. So that means that diagonal is strained. That diagonal is strained. Okay. So that diagonal strain can be extension strain. You can write it as extension strain of dB along dB can be written as NB dash. What is NB dash? That is a change in length, you can see, because of perpendicular drawn. So please understand. So this length is nothing but length of dB and dn is same. So therefore extra length is nothing but extra length of the diagonal dB dash is nothing but nb dash. So that is change in length. So therefore change in length nb dash divided by dB. Okay, dB is the original length of the diagonal. Okay, that is extensional strain along dB. Similarly, you can have compression strain along AC or CA. So this diagonal, you can see my pointer, the diagonal AC, get compressed. So because of that it is strained. That is, we can call it as compression strain. We can call it as compression strain. How you can define compression strain? Again, change in length to the original length of the diagonal. Original length of the diagonal. What is the change in length of the diagonal? Change in length of the diagonal, how you can get it? That is the reason why we have drawn a perpendicular. Again, here. So here you can see a perpendicular is drawn, that is A dash M. So CM and A dash C have the same length. So AM is the additional length, or MA. MA is a compressed length. Okay, compressed length. So therefore, you can write change in length to the whatever original length. Original length is AC or CA is the original length, CA. Change in length, how much it get compressed? That is MA is the amount by which it is compressed. Okay, amount by which it's compressed is MA. Okay, so MA by CA. MA by CA. Okay, all right. So you got extension strain and compression strain. So now look at that angle, whatever, what is that? B, B dash C. B, B dash C. Can you see the angle? B, B dash C. Is it 90 degree? It is given that B, B dash C. You can see my pointer, mouse pointer, B, B dash C. Is told that 90 degree. Is it 90 degree? Do you agree B, B dash C is a 90 degree? If you agree, put it as yes. If you don't agree, put it as no in the chat box. Do you agree? Yes. Madhu says no. Karthik says no. Yes. Sumukha says it is yes, sir. Okay. So let's see how many of you can see it as 90 degree. Yes. Mayur says no. B dash B, B dash C is right angle says. Okay, so it says yes. Okay, few says yes, few says no. Akshay says no. Okay, so now in my figure it looks like it is no. It is not right angle because it is deformed. Which one is right angle? ABC. Angle ABC is a right angle, 90 degree. Can you agree? All of you agree? If you agree, put it as yes in the chat box. Quick reply. Yes, yes. People say it is yes, yes. Okay. Right, right. So angle ABC is 90 degree. Correct, correct. Okay. So now in the figure B dash B dash C is not 90 degree. But actually what I told, just go back. What is our assumption? Theta is small. So in the figure it is a big. Okay. Whatever deformation given is very small. So let me mark in red. So let us say very small deformation if I give. Okay. So very small. Very difficult to mark for me. You can see in the red. Now just see B dash. Is it 90 degree? Do you agree? Because deformation is negligible, very small. So almost deformation has occurred, Deformation has occurred, but it is very small deformation, very small deformation. So therefore, B dash is equal to 90 degree. Okay, so therefore B dash is B dash C is 90 degree. So therefore, this angle is 90 degree. So therefore, angle B dash N, which is at B dash N. This angle you are talking about, this one. Okay. So B dash N, not complete angle. I made a mistake. So this angle we are talking about. Okay. This angle we are talking. So since DB dash is diagonal, so diagonal will divide angle into exactly two parts. So exactly half of that. So that means this angle is half of the 90 degree. So therefore it is 45 degree. Yes, fine. So therefore we can write NB dash is equal to, using trigonometry. I am using trigonometry. So because this angle again B N B dash, which is 90 degree, because it's a perpendicular drawn. BN is perpendicular to DB dash. So therefore, this angle is 90 degree. You have a triangle now. Okay. This is 90 degree. This is 45 degree. Angle corner of the B dash is 45 degree. Corner of B is 45 degree. Corner of N is 90 degree. So this is a right angle triangle. Right angle triangle. So let us use a trigonometry, and you can write NB dash, okay, that's the change in length. NB dash is equal to BB dash into cos 45. That is nothing but what you did. You used cos 45. Cos 45 is equal to what? Adjacent divided by hypotenuse. That is what exactly you have used. Adjacent is NB dash divided by hypotenuse is BB dash. So therefore, NB dash is equal to BB dash cos 45. What is BB dash? BB dash, just a few minutes before we have assumed that is AA dash is equal to BB dash, that's equal to small l. So therefore, L divided by what is okay, that is L divided by cos 45. Cos 45 is 1 by root 2. 1 by root 2. So therefore, you have L by root 2. Is it okay? Make sense? Okay. So NB dash is equal to L by root 2. L by root 2. Okay. Any question at this moment? Don't put anything in the question and answer, because I am concentrated on chat box. So if you have any question, please put it in the chat box, not in the question and answer section. Question and answer section I will use if I want to ask any question. If I am expecting you to give the answer, either I will use poll or question and answer. Don't use question and answer section. Yes, Ashwin, I think you have asked something. So can you put that question in the chat box? Ashwin. Because in the presentation, for me it becomes difficult. Okay, you put a yes sir in the, okay, fine. Okay, you replied in question and answer section. Don't reply in question and answer section. So if I say reply, put it in the chat box. Okay, this instruction for all of you, because in the presentation mode I can see only chat and participants. I can see you. If you raise your hand, I can see you. Okay, so I am concentrate on only on chat box. I'm not concentrated on question and answer. So that will come as, if you write something, it will come as question mark for me. Okay. So don't put it anything in the question and answer section. All right. Next. So similarly, previous slide you want to see. Okay. Akash. Okay, I will pause at this moment. I will go to previous slide. Yes. Yes. Yes, I have put the previous slide. Yes, what do you want to ask? Want to ask anything? Shall I go to next slide? Okay, thank you. All right. So we got the extension. What is the amount of extension? That is NB dash is equal to L by root 2. Similarly, you can let us try to get compression. The same way you can get the compression. The compression also same angle, that is A, I mean B dash, okay, B A dash D, B A dash D. Again it is 90 degree, using the same argument, okay. Sorry, you have to use argument. Monica asked CA is equal to MA by CA, or okay, I will come to that. I will make it clear. Wait. Okay. So MA dash compression strain. Okay, MA divided by CA. So now question is whether it is CA. CA is original, right? CA is original. Okay. MA dash. Okay, MA dash. So alright, CA is equal to MA dash. That is, what do you want? You want, it is not a change in. Okay, it is change in. So MA dash, what is MA dash? MA dash is this perpendicular length. Okay, MA dash is this perpendicular length. What is the compression? Compression is this compression of the diagonal, change in length of the diagonal, right? That is AM. That is AM. So therefore, CA is equal to MA by CA. It is not, what is that? MA dash. MA dash. MA dash is this length, this perpendicular length. Okay, clear? CA is equal to, is it clear? Mayur, is it clear? You also made confused, huh? Got confused? Clear? MA dash and AM are the two different length. Okay, okay, they are two different length. MA dash is perpendicular. Okay, AM is a change in length. Okay, coming back, AM is equal to AA dash, using same argument. So here right angle, that is this one. Okay, A dash C, A dash C. This you can use, or any argument you can use, or you can use this one. Which one? B A D. Okay, what is the angle? Angle is 90 degree. What is this? This angle. What is that? A dash A C. So this will be 45. Same previous argument. So therefore, A dash cos 45 is equal to L by root 2. Same thing. Okay, same argument, previous argument you can apply here. So you will get AM is equal to L by root 2. So therefore NB dash, so extension extension also L by root 2, compression is also L by root 2. Now, so what you can see is a dB. What is dB? dB is a diagonal of before deforming. CA is also diagonal before deforming. What is the length of diagonal? Length of diagonal is nothing but dB and CA are equal. Okay, dB and C, two diagonal are equal because it is a cube. That's equal to, you can use a Pythagoras theorem because length of the edge of the cube is L. You can see here, edge of the cube is L. So therefore using Pythagoras theorem, you can get, so both, it's a cube, all sides are equal. So therefore L, L. So therefore diagonal is equal to root of L square plus L square. Okay, root of L square plus L square. So that's equal to L into root 2. L into root 2. Is it okay? Okay. So next. Therefore, extension strain, somewhere we wrote here. You can see here. Okay. You can see here. Extension strain, we have defined extension strain, compression strain. Initially we have defined both. Now let us see extension strain. Extension strain is equal to NB dash by dB. What is NB dash? NB dash, just now you have seen NB dash here. This is the value of NB dash. NB dash is equal to L by root 2 divided by dB. dB just now we have found out. What is dB? dB is L by root 2. Yeah, sorry, L into root 2. So therefore, 1 L by root 2 divided by L into root 2. That's equal to, so what happens? This L by root 2 will come down. So root 2 into root 2, that is becomes 2. Okay, L by 2L. L by 2L. Okay, what is L by L? What is L by L? Here it is. That is L by L is theta. Correct. So therefore that becomes theta by 2. Theta by 2. So therefore extension strain along dB is theta by 2. Theta by 2. Okay. Make sense? Similarly, you can get compression strain. Okay. So compression strain, the same way you can get compression strain. So compression strain is defined as that is MA by CA or AM, that is one and the same. Okay, MA, AM, same. So here we wrote it as AM, don't get confused. So AM by CA. What is AM? AM just now we have seen, here it is. Correct. So AM is L by root 2. L by root 2 divided by CA. dB is equal to CA, that is one and the same. So L into root 2, that is equal to L by 2L. Correct na? Root 2 will come down and get multiplied. So therefore you are left with L by 2L. So L by 2L, L by L is nothing but again theta. Here it is. So therefore theta by 2. So extension strain along dB is theta by 2. Similarly, compression strain along C is theta by 2. Okay? Alright. So therefore, shearing strain, when you add compression strain and extension strain, you will get shearing strain. Shearing strain is a result of compression strain and extension strain. So therefore, extension strain plus compression strain, that is theta by 2 plus theta by 2. So theta by 2 plus theta by 2 is equal to theta. That is nothing but shearing strain. So that is a relationship between extension strain, compression strain and shearing strain. So shearing strain is nothing but sum of extension strain and compression strain. Is it clear? If you have any doubt, you can ask. Yes, if you have any doubt, you can ask. If you want to talk with me, you can raise your hand also. Yes, today's attendance poll is open. You can mark your attendance. Yes, anybody want to talk with me? You can raise your hand. Yes, you want to talk? Raise your hand. I will unmute you. Understood. Okay. All right. Clear. Any doubt is there? If you have any doubt, you can ask. No problem. Arun, now you can see the polling. Yes. Now can you see the polling? Varun. You are attending using laptop, huh? Just raise your hand. Varun, raise your hand. One second. Uh, Now you are unmuted. Yes. Are you attending using hello? Varun, can you hear me? You are unmuted. You can talk now. You are attending using laptop, huh? Computer. Varun, you can talk. You are unmuted. Directly you can talk. You can talk. Okay. If you are attending using computer, then there will be a issue. You cannot see the poll. So if your pop-up is blocked, you have to enable the pop-up. This, okay, you have to enable the pop-up. Then only you can see that. Laptop means you have to enable the pop-up. Poll is coming as a pop-up. So enable the pop-up, you can see that. Just enable the pop-up. It's blocking the poll, that's all. All right, so now you are getting Varun. Still it is open. Got the poll? Okay. All right. Let me close the poll. It's time. Okay, poll is closed. So, if any doubt, if you don't have any doubt, so I think it is, yes, it's already time. Tomorrow, let us see the different that's a relationship between different elastic constant that we will see tomorrow. Okay, so I'll stop here. So thank you for attending. Okay, thank you, thank you, thank you. Welcome.